Hi everybody, I'm Manal and this is Anna, and we're from Valley STEM. Today we're going to be learning about physics, the science of motion. Think about what happens when you drop something. It lands on the floor, right? That is because of the constant force known as gravity, the attraction between objects. Gravity is all around us and is always pushing us on Earth. If we lived in a world without gravity, we'd be floating instead of walking. That sounds crazy, right? This is because gravity changes all of our motion. It is attracting us towards the ground. But of course, this isn't the only force in our world. A force is a push or pull on an object, so consider what this means for us. Our weight is directly caused by gravity, pulling us towards Earth. This means that the force of our weight due to gravity is keeping us from floating away from Earth. Now, if we were to use our weight to push in different directions, that would cause motion. Even if we don't realize it, our brains are telling our muscles to push or pull in order to force us to move. And we can apply these forces from our muscles to other objects. Think about what happens when you bounce a ball. You're applying a force to the ball, and the more you apply, the higher the ball moves. Or when you throw a football, the more power you throw with, the farther the ball goes. If you're still not too sure what we mean, head to the link in the description. We have a quick activity for you. When it loads, click on the play button, drag and drop items of varying weights on the skateboard, and drag the applied forces to different levels. Test it out. Now that you have tested it out, what did you notice? Did it need less force for objects that weighed less? That is because the object itself is of less force, meaning that it will need less force to push it. By pushing something, you are removing it from its current position in which it is not moving. This will require a force that is much larger than the static friction force, or the force to make something move. If the object is heavier, then you will need even more force to move because the force is partially based on mass. If the object is already in motion, that means even more force will be needed to push it in another direction. That's because there is already a force being applied, meaning you must not only act against the static friction force, but also the force currently applied. Going back to the activity, to try out going against different forces, go to the net force icon, the first icon in the bottom center panel. See what happens when you add different people of different sizes who can carry more or less force than others. When I say go, drag and drop the people, and press go to see what happens in this game of Tug of War. Test this out for a few minutes and then come back. Go. Did you notice how big kids could push out more force? That's because they represented the stronger people of the groups and could push out more force due to their strength. Next time you play Tug of War, make sure you're on the stronger side. Now that you've seen how different forces can interact, consider the following questions. Good work today! If you're watching this video as part of our library or school programs, return to the digital session. Otherwise, if you ever need any help or have any questions, send us an email at questions@valleystem.org. We'll catch you guys at the next one.